Sorry. So, hello everyone, this is me Kalam Hussain here, and I am going to present my 15th practicum of Max here. And let us dive into the questions. Where the first question is to learning scenario one, which is learning rate decay in deep learning. The question is the train during the training of a deep neural network, the learning rate decreases exponentially after every approach to stabilize. The model, the following learning rates were recorded, approach and learning rate, and we got to find the exponential regression model using the least square method, and we got to determine the values of A and B, and we got to predict the learning approach at the rate 8, and we got to plot the curve, and let us dive into it. The first one is to import a py and import a matplotlib dot py plot as plt, and after that we are going to apply the values of x and y, and after that we are applying y values is equal to um, np dot log y, and after that n is equal to length of x, b is equal to, so these formula n power n times np dot sum xy minus np dot sum x times np dot sum y divided by n times np sum by x square minus np sum x by x square. Np sum power a is equal to np sum y minus b um, times np sum x by n, and after that we gotta use the values of small a and small b, which is np exponential A, capital A, and small b is equal to np exponential of capital B, and our fitted equation is so and so predicted. X predicted is np dot ln space 100, 110 and 100. Y predicted is equal to A times B power X prediction, and after that we are putting the XY label as subset data, and after that exponential fit, and the line says exponential fit, and after that we are we're giving the approach value and learning rate value, and plotting and showing, and after that we are printing out the values, and here's the output. The fitted equation is y is equal to 0.1519 bracket 7.904 times x. So there you go. This is value which has been shown here. You could see y is equal to 0.151. Okay. There you go. And now to the second one, which is similar to this learning rate decay in machine learning training. And here we got to find the transform. We need to transform the above exponential model into linear form using logarithms, and using the least square method. We are determining constants A and B, capital A and B, small e and b, and after that we got to write the fitted regression equation, and after that we are predicting the learning rate approach at 10 and plotting the observed data, and the steps are similar as follows. So x and y, capital Y, n is equal to length of x, m is equal to, here the value has been changed, mc, more like the formula is same comparatively to the first one here. C is capital B and A, but in this case it's been M and C, and A and X prediction and Y prediction. After that we are labeling out as follows, and plot show predicted, and after that we are the fitted equation onto the output, which is the fitted equation is y is equal to 0.1223 times e power minus 0.2001 time 1x. The predicted learning rate at approach 10 is equal to 0.01653, and so on. The graph is shown here, and the observed data is print as from 1, 2, 3, 4, 5, and 6, and the lines exponential fit has been decreasing accordingly. So according to this values, the graph has been applied here, and the formula is similar to the which was already given there, and y is the one also. No, the M is similar to B, C is similar to the A1. Yeah, and there we go. And on to the third one, which is internet traffic growth and network server. And here we got to convert the above model into linear form using logarithmic transformation, and we got to find the least square method, determine the parameters capital A, that will be small b, and small a, which is small b is technically M and C, and Yeah, and obtaining the exponential regression and predicting the request after 8 hours, which is here time. After six, we got to predict the eighth one. After that, we are plotting the data traffic, and here is it. We are putting numpy by SMP. Plot loop p by plot, which is already given here. X5 is also given already done. Y is equal to np dot log y. N is equal to length of x. M is used to as the formula, and C is also used to similar to that. A is equal to np dot exponential C. Fitted equation. The print if double slash y is equal to a times dot 4f times e power m 4f x, and after that we are predicting x and y 1 9 and 100, and y is equal to a n p exponential mx prediction. After that we are scattering x y as absolute data, and prediction x prediction y prediction and labeling as exponential fit, and after that we got a labeling timers and requests, and after that we are plotting it and showing, and we are printing out the values, and here is it, the output. The fitted equation of the question is y is equal to 85.1078 times e power 0.3687x, and predicted traffic after 8 hours is 1625.4007685593.7.5 hours. Sorry, the predicted is request per minute. Calculators in minute, and here we go, which is given. These values have been arranged accordingly to the graph which has been described there. And yeah, this is the overall practicum 15, and there you go, this is it. Third one, there is the output, there is the question and code. Second one is the output, is the question, output, the graph, code, and question. And there you go, this is it. And thank you.